with Kepler in order to achieve this. Now Kepler, again, for those of you who aren't familiar, it's a code name for our latest architecture. The architecture is just basically the basic building blocks of the GPU, and we use that architecture through the entire range of our 600 series GPUs. And from a very basic level, this is just a basic building block of a GPU. We call it the SMR stream multiprocessor, and this is what it was in our last generation. It, again, from a very high level, consisted of a bunch of processing cores. This is kind of similar to what you'd see in a CPU that has 2 or 4 cores. Obviously, these are much different cores, but it's conceptually like that. These are the processing cores that basically do the work, do the graphics work. And then on top of that, there's a block that's called control logic, and that basically just directs the traffic. And you get this big load coming in from the game, and it splits it out to all the different cores and tells them what to go do. And so this is, from a very high level, what the basic building block of our GPU used to look like in our previous generation. With Kepler, what we've done is we've gone and added a ton more cores into that basic building block. Okay, we've done this in 2 ways. One is just through microarchitectural engineering, and the second is through process technology. We can use smaller process technologies to shrink everything down and fit more processing units into a single processing block. But really, the other thing we did is we reduced this control logic. So the area that is directing traffic, we've moved a lot of that intelligence up into our software stack, so it's not taking up room in the die. And that allows us to not only make this faster by sticking a whole bunch more processing cores into it, but also make it a whole lot more power efficient. And at a fundamental level, this GPU is twice as power efficient as our previous generation. So that's over the course of 2 years, we've doubled the power efficiency of the GPU. And so, as a result, we've put together the fastest and most powerful GPU ever made, and that is Kepler, and that's what the power and the graphics card I showed you here to power this PC that we're showing you here. And so, obviously having that horsepower is just a prerequisite to be able to play back a lot of the latest and greatest titles. And let me show you, instead of telling you, I'm just going to give you a little demo of what it means to be packing this much more processing power and power efficiency into a single GPU. I'm going to show you guys a demo here. This is a demo from Epic of their Unreal Engine. You skip ahead a little bit because it's kind of long. This is called the Samaritan demo. And I'm showing you guys today as a video. Unfortunately, they didn't want us taking the source code outside the country, so this is a video of it. It is a real-time game engine. Okay, this is using an Unreal Engine, meaning this is technology that can be used in a video game. Okay, and being rendered in real time. Now, Epic created this demo and first showed it at the Game Developers Conference in 2011. And it uses all the latest and greatest lighting, shading techniques. It uses NVIDIA physics. It uses just an absolute ton of technology to make these images so realistic. Now, back when they showed it in 2011, they needed 3 of our fastest and highest end GPUs in order to run it. Okay, that was 3 GTX 680s. That was a total of 750 watts of graphics, just graphics alone. The 3 of those graphics cards combined cost about $1,500. It was, to say the least, a very high-end setup. And you can imagine, some of the noise and the heat that much horsepower generates. So just 1 year later, in 2012, this year at the Game Developers Conference, they showed this demo again, and they showed it on a single GPU. They showed it on a single GTX 680 GPU. And that single GPU was, and still is, a $500 GPU. So it went from what used to take $1,500 now to $500. Instead of taking over 700 watts of power, our GTX 680 can do it with 195 watts. Okay, much quieter, much less power, much less heat. And all of those advances were made due to, first of all, a lot of work we've been doing in the realm of software to help make these games just as beautiful and much more efficient. But also, of course, the hardware that we've created. Okay, so that's really what Kepler did. Is it allows this level of graphics fidelity, this level of interactivity, and it makes it much more accessible. Right? Most people aren't going to buy